So let me get to the ellipse. All right, so at least whether I can get started with 10.2 is not that big of a deal today, but I do want to make sure that I start while I do finish the ellipse in a strong way. All right. I think that for this class, we talked about quite a few things about ellipse, right? We even got to the graphing part, right? Just to show you how straightforward it is to even plot it, right? With the graphing utility. So now let's get a bit more professional, especially when it comes to referring to things like those special points, right? The dimensions, measurements of ellipse. Starting with the so-called major axis. So major axis is the length of the ellipse. Okay, so if you remember what I said about comparing the ellipse to a rectangle, right? It looks like a round rectangle. So we've been stretching the ellipse either horizontally, right? Make it a little bit longer that way, or stretch it vertically. So this is what I mean by the length of the ellipse. But instead of calling it length, we call it major axis. So that's basically the longest segment, right? You can draw with 2 points on the ellipse. So now the segment that is perpendicular to the major axis going through the center of the ellipse, right, with endpoints on the ellipse, is called the minor axis, which, as you can tell from the graph, it's pretty much what I call the width, right, of the ellipse. So major axis, right, minor axis, but even if you turn it 90 degree, either one way or the other, you still have the longer measurement, right, to be called as major axis, and the shorter side will be the minor axis. Endpoints of the major axis is called the vertex, or two of them, right, vertices. But somehow we didn't have the endpoints. We didn't have the name for the endpoints of the minor axis. Okay. Center is the center, just the center of the entire shape. So major axis, minor axis, right? Vertices, things like that. Now, of course, you don't see the focus, right? Or the plural form, foci or foci. It turns out that both foci must be on the major axis, symmetrically located on either side of the center. Okay. That means if it's a vertical ellipse, then you have the vertices, the foci, and the center all line up on a vertical line. Okay. Now, moving on. So again, I wish I have the time to show the algebra to turn that ugly equation about define the ellipse, right, using the sum of the distance from the P to the F1, F2, right, to be a constant, somehow eventually becoming a much easier equation to deal with, right? But, not that important, but let's be practical. So what you really have to take away from this packet 10.1 is, these two standard form of equations of the ellipse, okay, and their corresponding graph. The one on the right, the one on the left, in the form of x squared over a squared plus y squared over b squared equal to 1, that is the equation for a horizontal stretched ellipse. Here, the a and a b are the half of the length and the width of the ellipse. Therefore, we call a, I think it's somewhere out there, right? A the semi major axis, and a B, the semi minor axis. And since we call them major, minor axis, or semi-major, semi-minor, A is guaranteed to be greater than the B. Okay. If it's a horizontally stretched ellipse, as you can see that the length or the major axis is 2A, right? That means you're going to go from the center to the right and left, right? By A units, you're hitting the vertices. And the segment connecting the two vertices is the major axis. The vertices are located at positive or negative A, comma 0, right? It's a horizontal ellipse. The two endpoints of the minor axes are on the y-axis, right? Located at 0, comma plus or minus B. Where the two foci are at C units to the left or to the right from the center, right? Therefore, it's plus or minus C, comma 0. Okay. And when it comes to the test for chapter 10, you're probably going to have to deal with the graph, the equation, back and forth all the time. So there could be questions asking you, just by looking at a graph, can you tell me what the equation might look like? By finding what the A and a B and a C. Okay. Or giving you the equation, can you plot, because you don't have to plot the ellipse in a test, right? Can you match that equation with one of the following ellipses? What's a horizontal or vertical, right? If the endpoints of the major and minor axes are correctly plotted, things like that. But now if you're looking at the one on the right, you have a vertically stretched ellipse, right? So now as you can see, the graph shows you the vertical side is longer, right? So you have still the center at the origin, but going up and down, right? By A units, you're reaching the two vertices, right? Going up and down by C units, you're getting the two foci, but horizontally, right? To the left and right by B units, you're getting the two endpoints of the minor axis. Okay, nothing hard to remember, right, or to comprehend them. But the problem is there might be a lot, to keep track of. So if you figure out a way to memorize them before the test and put them on a cheat sheet, the spreadsheets, you could do that. But the problem is, in the past, people screw up even just by putting these down on a spreadsheet because they messed up the location of the A and B. So I just want to make sure that you do find the big difference between these two equations. And the first one, the one on the left, why? To me, it looks like a horizontal ellipse. Because A is greater than B, right? Because that's why we call A the semi-major axis. If A is the larger number, do you see that the larger number is underneath the X term? That means the horizontal, the X direction is going to be longer. And therefore, it has to be a horizontal ellipse. So now if you swap the A and B, you're going to be getting a smaller number, relatively speaking, a smaller number underneath the X square to get a vertical, because it makes the vertical direction, the Y direction, right, longer. Right, so that's a vertical stretched ellipse. And it turns out that those are all you need. The terminology, the matching between the term, right, the name, semi-major, semi-minor, right, vertices, foci, and those, parameters, right, or real numbers like A, B, and C. So now let's try actually working on a problem. It's actually at the test or quiz level, like letter A. So they wanted to graph, but we just have to get those things ready. Then later on, the graph is a lot simpler than you thought. So it's an equation which is coded both x and y. But to extract those information about the foci, the major axis, minor axis, you need to know what A, B, and C are. But you need to first write the equation in the standard form to see what those parameters are. As you may recall, the standard form has a 1 on the right-hand side of the equation, but we have 225. So what I have to do is just divide it out. But make sure you divide out 225 across the board. I mean, you may or may not see that 225 has a factor of 9, right? But if I want to match this equation with a standard form of x squared over some number, right, plus y squared over some other numbers, right, equals 1, I need to get rid of that 9, right? How do I do that? Well, why don't you just divide out the 9 on both the numerator and denominator? So you're looking at x squared over 225 over 9 plus y squared over 225 over 25, right? So 225 over itself, it will be 1. Don't worry about those numbers, right? So most likely the test will have those numbers that, do simplify, but sometimes they might have some fractions waiting for you. So in this case, 225 divided by 9 is 25. You get x squared over 25 plus y squared over 225 over 25 is 9. Okay, and you get, the 1. Now, one of my students in the AM class asking me, is that always the case that basically the numbers in front of x and y get swapped and get underneath? The answer is no. Right, so that's why those questions from the book are way too easy, and you do have to see those complications from the review packet, and of course, the homework in Pearson. Okay, but at least that you see the reason why they use those easy numbers is you can easily tell what the A and the B is supposed to be, right? Now, do you guys see which number should you use to find out what the 8 is? If we were looking at, no, I can put, well, you have the packet, right? So if you just go up there, to see what the standard form of the equation of ellipse looks like, it's either going to be a squared here or b squared here, right? But which number? Is it 25 or 9? Will be the a. Okay, 25, and the reason is 25 is the larger number, right? Because when it comes to A and B, you pick the larger number and call it the major or semi-major axis, right? So it'll be square root of 25, right? Remember that it's actually a squared underneath the x squared. So that'll get you 5, right, for the A, and B is going to be square root of 9. So that'll be 3. Oops, sorry. All right, so now here's something that please make sure that you remember. So I believe that is the reason why they use the lowercase a, b, and c. Once you get a and b, right, semi-major, semi-minor, the way you can find out what the c is to apply things just like the Pythagorean theorem. So the distance away from each of the foci to the center and the semi-major and semi-minor happen to work out as if there are 3 sides of a right triangle. So the square of the sum of the c and the C and the b add up to be a squared. Therefore, you get 4, right? 5 squared, 25 minus 3 squared, which is 9. So you get 16 on the square root of 16 is 4. 3, 4, 5. So now what else do we need? We need the foci, right? The vertices. So let's look at the foci. Is that ellipse a horizontally stretched or a vertically stretched ellipse? It's a horizontal, right? Because you have 25, which is a bigger number underneath the x squared. If it's a horizontal ellipse, so I guess I don't have to scroll it up that much. Do you see that? When the center is at the origin, to find a foci, just go to the left and right by c units. In this case, will be 4. You say that the foci could be plus or minus 4, comma 0. You can write them separately, 4, comma 0 and negative 4, comma 0, right? But it's just going to be, more compact that way. Now, what about the vertices? Vertices. You guys do the same thing to find out what the coordinates are, the same way like you did with the foci, right? Or take a look at the graph, the horizontal ellipse. From the center, which is 0, 0, right? How do I reach the vertices? The endpoints of the major axis. Right here, right? One there, one there. So you have plus or minus 5, comma 0. Okay. What else do we need? Foci. Okay. The major axis and a minor axis, not semi-major or semi-minor. That means we're looking at 2a, right? Twice as much. So that is 10. And the minor axis will be 2b. So there'll be 6, right? And that's it, right? Or if you want, just to make it clearer, center is 0, 0, the origin. So given all of that, right, you should be able to graph the ellipse. Okay, or at least that it's very easy for you to picture. Oh yeah, go ahead, Lucia. That's a good question. So maybe it was the guy who wrote the book decided not to call that some kind of a vertices. Right, but there's no name, right? So the points. So basically, Lucia was asking why we're calling the endpoints of a major axis vertices, right? But what about those 2 points? They are the endpoints of a minor axis, right? But somehow the book decided not to call them anything. Just some points. All right. Now the graph will be pretty straightforward, right? So there's not a space, for me to put an ellipse like that, but I can quickly show you. Or you know what? If you don't mind, let me go to the other page. An ellipse has things stretched horizontally, and it can go as long as 2a, which is 10 units, as y as 2b, right, which will be 6 units. So would you say that it will be ellipse like that or something like that? I did my best, right? So it would be 3, negative 3, right? Negative 5, and a 5, right? With the center, right, at the origin. Now, if you do want to label the foci, you didn't have to. Negative 4 and 4. That's all. That's an ellipse. But all you have to do is match the graph, right, to get to choose one with the equation that you saw on the previous page, right? Anyway, so now go ahead and take some kind of a vertices. I don't see any problem with that. Now, so letter B is pretty much the same problem, right? It's just repeating for a vertical ellipse. So let me just quickly get the work in. So we're going to rewrite that equation by dividing everything by 400 to at least get us, a 1 on the right-hand side of the equation, right? And once again, this guy figured those easy numbers, but don't get spoiled, right? So numbers could be fractions or rational, irrational in the actual test or the quiz. But in this case, if you divide out a 25 in the first fraction, divide out a 16 in the second fraction, you'll be looking at 16 on the first denominator and 25 on the second denominator. Okay, But don't worry, you're not going to get this kind of a carefully prepared example all the time. At least that little c, not to mention one more example, you see that the more realistic numbers to deal with. Anyway, now right off the back, is that a horizontal or vertical ellipse? Vertical, because you have a larger number right underneath the y square. Therefore, a will be the larger number, right? Square rooted, since a squared is 25. Okay, so you see how crazy this guy is about the 3, 4, 5. So again, you're getting the b, right? Radical 16, so that's 4. And to find out what the c is, you just do the square root of the difference of the squares of a and b, right? So you're going to work it out as 3. So again, we're looking for foci, the what do we call it? The vertices, right, and the length of the length of the major and minor axes. So now let's try something at a slightly higher level to make sure that you're not trying to memorize these things randomly. If you do that, you know, you'll stress yourself out in a test. If I want to locate those points and figure out what their coordinates are, I need a sketch to remind me where they're supposed to be. Okay? I'm sure that everyone can easily sketch a ellipse, right? Knowing that it's stretched vertically, right? And it has the length to be 10 units. That means 5 units up, 5 units down, right? Width to be 8 units. So 4 to the left, 4 to the right. Is that okay? And also, if you want to label the points, right, do that, and you know, reminding yourself, it's vertically stretched, right? So you get 5, -5, right? That's the semi-major, right? Then here you have -4 and a 4. Where should I put the 2 foci on this graph? Somewhere on the ellipse, or on the horizontal, or on the vertical axis? On the major, on the vertical axis. In this case, the vertical one, right? So the 2 foci should be here, right? But they should be up and down by how many units? C units, right? And like Lucia was asking me, is the name for C? Yes, focal length, distance from the focus to the center. So this guy will be 3 and -3, right? So now, just go ahead and read off the coordinates. Foci, it's on a vertical axis, right? So it'll be 0 plus or minus 3. Vertices, 0 plus or minus 8, right? Which is 5. And again, the length of the major axis. So let me not get too lazy. Length of major axis, which, as you know, is the same as 2a, right? That will be 10. And the length of minor axis is 2b, which in this case is 8. Oops. Just in case if you wonder where the center is, center of the ellipse is at the origin. Okay. All right, everything okay so far? Going one way from the equation, which is not even the standard form, into the standard form, extracting the ABC, you know, using a sketch to remind you what those points are, right? And read them off. Or what if I provide you those points or some information about the major, minor axes? Would you be able to construct the standard form of the equation of ellipse, like letter C? Find the standard form of the equation of ellipse with foci at plus or minus 1 comma 0, vertices plus or minus 2 comma 0. So the first thing you have to tell me is, does that look like a horizontal or a vertical ellipse, given the foci in ellipse? What do you say? Plus or minus 1 comma 0 are the foci? Plus or minus 2 comma 0 are the vertices. Should that be a vertical or a horizontal ellipse? Horizontal. And you have the packet there, right? So if you just go to the page where it has the two ellipses, right? See which ellipse has the foci and the vertices, right, on the x-axis. So it's a horizontal ellipse, and it goes like x squared over a squared, y squared over b squared, right, equals 1, right? So you know what the 8 is, right? Because that's what numbers you use for the vertices. So it'll be 2. The C, right, the focal length, it's 1. So now instead of finding the C, you find the B the same way, right? Taking the square root of a squared minus c squared, because a is always the largest. And you get square root of 4 minus 1. So now you're getting some ugly numbers, right? Radical 3. Well, it's not that bad, because you're gonna square the b, right? That means the standard form explicitly is gonna be x over a squared. So x over 4 plus y squared over 3, radical 3 squared, so will be 3, right? Equals 1. Right? All right, cool. But anyway, so any questions before I move on to the so-called translated or shifted uh, ellipse? Okay. So I guess that the reason why you're asking, the purpose of the C is you don't see the foci on the ellipse, right? So it was the focus, or the C defines this the ellipse. So those are the two reference points. Yeah, but I'll get to that in a second. Yeah, Samantha? It's the B square that underneath the Y, right? Now, so okay, so now again, everyone, think about that question. If you were me, how would you answer the question? What's the purpose of the C? So you guys remember, I defined the ellipse using the real situation that you have to travel, right, from your the school to maybe your friend's house, then go back home, right? On your way home, you visit somewhere, right, either a friend's house or grocery store, right? But somehow you're limited to only 10 miles, right? So because your scooter only have that much, mileage. But do you see that your home, so your school and your home are the two reference points in the space? Only by specifying what the two reference points are, you get to define where the ellipse is. Okay, but somehow people thought that those two reference points are going to be on the ellipse. No, they're not, and you don't even see them, right? You don't even have to graph them because they were somehow hiding behind the scene. It's like I told you, the sun, right, in our solar system is at one of the foci, and the Earth is the point P, planet going around the sun, is going around the sun in an elliptical way. So can you imagine that? What if the sun is in a way somewhere on the ellipse? No, the Earth's gonna hit the sun, right, in a year, right? So thanks to whatever you believe, right? So either physics or God, that sun is 9 away. Anyway, now, but realistically, we're not always given an ellipse centered at the origin. So you might end up getting a shifted one. So as you're looking at the standard form of, let's say, a horizontal ellipse centered at the origin, and the one on the left, it's the same ellipse, but now it's centered at H and a K. Okay. So this is what a shifted ellipse looks like, right? So now let's say this is the ellipse that we figured out, right? And I think that it's x over 25 plus y squared over 9, right, equals 1. So what if I want to figure out the equation for an ellipse with the same shape, the same size, the same orientation, but I don't want the ellipse to center at the origin. So I want to, oh, it doesn't let me, you know what, I'll still do it. So I have the new ellipse located at, let me see how much that is. Wait, why is there a 5 there? Let's get rid of the 5. So the new ellipse is located at, say, 4. And maybe 2, just make it a bit easier. But I'm telling you, the new ellipse, even though that the center is different from the origin, it's the same exact ellipse, right? How would I write the equation for the new ellipse, the one that has been shifted, in the same format? And see how straightforward it is. The new ellipse, the new one, is x minus 4 squared over 25 plus y minus 2 squared over 9 equals 1. Now I should have used the same color for the 4 and 2. Do you see the new location of the ellipse and how it enters the standard form of the ellipse? And that's by shifting, or it's basically just take that ellipse and put it at 4, 2, right? Or the center of the ellipse, right, at 4, 2. But at the same time, do you see that the vertices, the foci, right, even the endpoints of the minor axes are shifted the same way? So my question for you is, can you still figure it out, the location of the new vertices, new foci? And you know what? Let me put down what you already know. So for this guy, you guys tell me what the foci are once again, because you already figured it out. The old one, where are the foci? A is 5, B is 3. I believe that C is 4, right? Would you say that it's plus or minus, 4, 0, right? What about the vertices? Plus or minus 5, yeah. But now, on the new ellipse, the foci and the vertices will be shifted the same way as you shift the center. But how do we shift the center of the ellipse? We shift it to the right by 4 units. We shift it up by 2 units. Where do you think the new foci and vertices will be located? if you're going to shift them to the right by 4, shift it up by 2. So the foci, now shift it to the right. That means you are adding to the right, right? You're adding numbers. You're adding actually 4 to the horizontal coordinate. Does it make sense? You're making a point more to the right. So here's I'm going to put the new foci plus or minus 4 plus 4. Oops, not 0, because we shifted to the right, but also we shifted upwards. That means I'm going to add 2 to the y coordinate. That makes the y coordinate 2. But of course, if you don't like the compact way of rewriting it, go with the plus. It will be 8, 2. One of the vertices, right? The other one is, interestingly, 0, 2. Because it was shifted, right? So now, can you guys do the same thing for the vertices? Well, then you tell me what the new vertices will look like. Vertices. Let me zoom out a little bit. Again, we shifting to the right by 4, shifting it up by 2. What does the horizontal coordinate look like? Plus or minus 5 plus 4, and the vertical coordinate. Yeah, that's it. Okay, so now we'll come back to this. So, but you see that we figure it out just by looking at the unshifted one, understanding how to locate those points, right? Then remind yourself that we shifted it. So now what happened if you have to do it in a more generic way? So h and k don't have to be positive, right? Who says h has to be 4 or positive 4? It could be negative 4, right? K could be negative 2. That means instead of shifting the ellipse to the right, you could shift it to the left. You can shift it down, right? It depends on the sign of h and k. But what's the point of memorizing those general formulas as if they're like random formulas? You could do that. But I believe that you have so many things to remember. Make sure you remember only the important things. If you can figure it out with logic, there's no point of wasting your brain cells on remembering them. All right. But if you choose to do it, make sure that you remember it the right way. So I know that, you guys will probably put down those formulas, right, for our third test or the quiz, or in the quiz that you have access to the packet, right? But is that thinking about the way I showed you to make sure that you're not going to mess up the vertical or the horizontal, ellipse. Also, when it comes to shifting it, okay. But again, I do have a chart which is straight from the book to let you know that if you do want to just blindly follow the formula for a shifted ellipse, right? Find out what the h and the k are, right? A's and b's, right? What is the vertical horizontal ellipse? You could do that, and you can read off the vertices, right? Or even just write down the vertices using the formulas. But I hope that drawing a sketch, thinking about how things got shifted, will be the way that you should try, in reality. Now, the last thing we have to make sure that everyone is able to do, at least at the level of the third test, is to write the equation of ellipse in the standard form by completing the square. Okay. And not to mention that it will be a shifted ellipse. So do you guys still remember maybe back in, middle or the first 2 years of high school, or even fall semester, the technique called complete the square? Okay. So a fun fact, that's a very important technique. Even I have to do that on my thesis. If it's not the same way as you will normally expect from a regular algebra, but the idea behind one of the things I did, in graduate school is pretty much just about completing the square. Okay. Anyway, now, in this case, unfortunately, you have the x terms, right, the y terms, and also you have the linear terms. The coefficients in front of x is not trivial. So I wish that I have. Now, so I want to see that if you guys do remember how to complete a square. All right. So how do I complete a square for these two terms? B over 2. So in this case, it will be -2 over 2, right? You're going to, okay, square and add it to the two terms, right? And you're going to factor it because that's the whole point of completing a square, right? I need to write it as a perfect square. It's going to start with the x. And this is -1, right? So it'll be x minus 1 squared. Right? Is that what you did before? Right? Everyone's, understand that? Okay. Now, what about x minus 3x? How do I complete the square? The same way, right? We just say that you're going to add not integer anymore, be -3 over 2 square, right? And that will be x minus 3/2 square, right? But this works only if you have 1 as the quadratic coefficient. We don't have that for this problem, but there's a way to, work around with it. But let me first rewrite the equation to group the terms I have to deal with. Right, let's say the terms, right, the both terms involving x, and I'm going to have some space here, and I have 4y squared plus 16y, okay? And I don't need that -11 for completing the square, so I'll throw that to the right-hand side. It'll be 11, okay? So I'm just rewriting the terms. Now, if I want to use that little technique, right, b over 2, right, square it, then I need to get rid of that 9. And typically, there are two ways of doing it. The first way, I believe that a lot of people will do, is to divide out a 9. But if you do that to this equation, you end up dividing the coefficient in front of y by 9 and getting some ugly numbers to deal with. So I suggest that you factor out the 9. But don't factor it out overall. Just factor out the 9 from the first two terms. Okay. So now let's say I'm going to put a bracket. All right, so I'll factor out the 9. So I left it with x squared minus 2x. Right. You see how I did that? Just take out a 9, right? And I'm going to have that bracket, and the reason I'm leaving a space, because I'm going to add some additional terms. And I'll do that, to the white terms. So I'll factor out 4. So I have y squared plus 4y. Again, leave some space. Okay. So does everyone see how I go from the first to the second line? Okay. So now we can focus on just the x squared and the -2x, right? The way to complete the square is to add half of b, right? Or b over 2. So -2 over 2, right? Square it, right? So in this case, we will do the same thing. We're adding the 4 over 2 square. Okay. Okay, so now the problem is that's an equation. How could you just add a number, right? Because that changed the whole equation. Completing the square or keeping the same equation, you have to do something to compensate, right? Which you just did. There's an easy way to do it. If you add a number, just go ahead and subtract it off, right away. I added a number, and I subtract it off, right? In this case, let me get the bracket a bit farther. So I added 4 over 2 squared, and I'll subtract it off. All right, so now the first three terms in each bracket can be factored as a perfect square, right? So you're going to go with x, and whatever number that was in there before you square it, it will be -1, right? You just stick in there with the x, and it's going to be x minus 1 squared. But this guy's still there, right? Don't forget it. -2 over 2, that's -1 squared, it will be +1. So you're going to subtract the 1, okay? With the bracket, with the 9 in front. All right, so now let's try that with the y terms. 4 is there, right, in the brackets. So the first three terms in the y becomes y plus whatever that number it is before you square it. So 4 over 2, that's a 2, right? Put it together with a y, square it. Then you have to take that into account, right? Subtracting 2 squared, so subtracting 4. I guess I could have made the bracket a bit closer. Okay. Now we have pretty much what we need, right? But we need to get rid of those excessive brackets. So distribute a 9. You get x minus 1, well, 9 times x minus 1 squared, right? Minus 9. Here distribute a 4, 4 x squared, y squared. Y plus 2 squared minus 4 times 4, 16, right? Equals 11. Add the 9 and 16 to make sure that all the constants go to the right-hand side. So you get 9 x minus 1 squared plus 4 y plus 2 squared equals 36. Okay, just by adding a 9 and 16. All right, so while you guys can do the last step for yourself, I want you to turn that equation into a standard form. And the standard form should look like x minus 1 squared over something, right? Plus y plus 2 squared over some other things equals 1. So what do you think that goes underneath x minus 1 squared? If you needed a 1 on the right-hand side, but you had 36. You divide 36 across the board, right? And you notice that 36 happen to have a factor 9, so it doesn't have to, but the 9 get crossed out. So you have a 4 underneath x minus 1 squared, and this guy works out as a 9, right? But again, don't spoil yourself with those easy numbers. In Pearson or the review packet, things aren't that straightforward. Okay, the ultimate goal after you complete the square is once again identify foci, vertices, semi-major, semi-minor, what else? Yeah, things like that, right? The coordinates, but now with the shifted ellipse. And I think that we could write it out to make sure that we're all on the same page, right? So let's say the ellipse we just got, x minus 1 squared over 4 plus y plus 2 squared over 9, right, equals 1. Now, let's do the same process once again, right? So it should be quick. Well, first off, it's a shifted ellipse, right? So how did I shift it? Or let's say, what is h and k? What did it say? H is the horizontal shift, right? Or let's say that location of the new center. See that it's the number that you're subtracting from the x, right? So that will be 1. Now, what about a k? The k be 2? -2. Yes, -2. So make sure to pay attention to the sign change. So now you see that it's shifting everything to the right by 1 unit, shifting down by 2 units. So now, what are the a and a b? Anyone figured out what a it is? A should be the bigger number, right? So it's gonna be 9 squared. Oh, sorry, not 9 squared. It's gonna be square root of 9, right? Because a squared is 9. So square root of 9, looking at 3. And b must be square root of 4, right? So that'll be 2. Now you need to see to find out what the where the foci are. So you're gonna be looking at square root of a squared minus b squared. So that would be square root of b squared is 9, right? Minus 4, so radical 5. Now, unshifted foci, unshifted vertices, okay. And then of course, we'll have shifted, because the ellipse is shifted, right? Shifted foci and shifted vertices. So now, is this ellipse a horizontal or vertical one? It's a vertical ellipse, right? So when it comes to a vertical ellipse, the foci and the vertices are 0 plus or minus c, or 0 plus or minus a, right? So in this case, c is radical 5, so plus or minus 0 comma plus or minus 5. And unshifted vertices will be 0 plus or minus a, right? So it'll be plus or minus 3. You guys with me? Unshifted one, right? Just playing with the a and c. But shifted foci. Can you guys figure it out? The shifted foci based on an unshifted one? We're shifting to the right by 1, shifting down by 2. What do you think will be the x-coordinate of the foci after the shift? Shifting to the right by 1. That means if we were looking at 0, it will be 1, right? Now, vertically, you have a plus or negative, negative 5, but a radical 5, but you're shifting it downwards by 2. You'll say that it will be radical 5 minus 2, right? That's simple. So now, you do that for the vertices. What do I put for the horizontal axis coordinates? Should the vertex have the same x coordinate as the, okay, so because they line up, right? So it'll be 1, and you know what? It's even the same exact structure. That's all.